Hey guys, today we are doing chapter 21 notes. Just a quick recap. Chapter 18, we went over the difference between sample proportion and sample mean. The entire rest of this unit is all sample proportions. And so in 19, we talked about confidence intervals and how we can reject or retain a hypothesis based on if it falls within or not of that confidence interval. And then chapter 20 was on p-values. So when you found out that your p-value was less than 0.05, you rejected. If it was greater than 0.05, you retained. So today we're just going to go in a little bit more detail about that p-value. That p-value is actually called the significance level or the alpha level, that 0.05 we've been using. So it is the threshold we use to determine whether the results of our hypothesis testing indicate rejecting or retaining. We almost always use 5%. It is by far the most common. However, you may possibly see ones such as 10% or 1%. The general rule behind this is that if it does not tell you what alpha level to use, then you use 5%. If it does tell you, you would obviously use the one it tells you. So your p-value, like I said, if it's less than your alpha level, we reject the null. If your p-value is higher than your alpha level, we are going to retain the null. Make sure you state that correctly, how we practiced in the last chapter. So when you're dealing with confidence intervals, your alpha level is half of the difference between your confidence level and 100. So for instance, if we're doing a 90% confidence level, it has a 5% alpha level. There are two different types of errors. You need to make sure you know both. They are very, very similar, so I find it easier to just memorize one of them, and then the other one is the opposite. So a type 1 error is when you reject the null hypothesis, but it was actually true, so you should have retained it. A type 2 error is the opposite. It is when you retained your null hypothesis, but it was actually incorrect, and so it should have been rejected. Like I said, these get mixed up so easily, so I find it easier to just learn one of them, and the other one is the opposite. So let's do an example here. It says, a production manager on an assembly line must monitor the output to be sure there is no more than 2% of their products that are defective. They periodically inspect a random sample of the items produced. They will shut down the assembly line if they believe that more than 2% of the items they believe are defective. So my hypothesis would be, that's a symbol for null hypothesis, and then p equals, we're always using p in this unit because it's proportions, 0.02. That's what we're looking at. My alternate would be, and now be careful, this is always going to be not equal to, less than, or greater than. So they will shut it down at the assembly line if they believe that more than 2% of the items are defective. So this is greater than 0.02. Okay, so if I end up sticking with my null, that means that I do not have more than 2% defective. If I go with my alternate, I do have more than 2% defective. It's your null and alternate. Do not forget that when you are doing these on your test, it will not tell you to list the conditions, but you always have to anyway. So remember, your conditions are that this sample is random and independent. I'll write these down. You have to put them in context. Okay, you have to have 10 successes and 10 failures. And you have to have 10 times your sample size. Okay, so make sure you write these down in context. You absolutely have to do this every single time. All right, but that's not the point of this unit, this chapter. The point of this one is to learn the different powers, or the different types of errors. So it says in this situation, what is a type 1 error and why is this bad? So remember, a type 1 error is when I rejected and I should have retained. So I rejected my null. I went with the alternate when I should have retained. So if I went with the alternate, I am saying that there are more. So if I say there are more than 2% defective products. When there's not. Okay, why is this bad? Because I'm going to shut down my assembly line. If I believe that there's more than 2% defective products, I'm going to shut down my assembly line. I do not want to send out defective products to my consumers because then they will not purchase from me again. So if I believe that there's more than 2, I'm going to shut down that assembly line and try and fix the problem. But if there's not really a problem, I just wasted a whole bunch of money where I could have been producing more products, but I shut down my assembly line to try and correct it. So that's a type 1 error. A type 2 error is the opposite. So it is when I retained my null. So I believe that there is only 2% defective products. When there's actually more. So why is this bad? Because if I say that, no, I only have 2% defective products, my products are doing just fine, but really there's more than 2%, that means I am now shipping out more than 2% defective products. I am going to have a lot more or the people are going to have a lot more problems with whatever I'm creating. So make sure you know the difference between a type 1 and type 2 error. Again, always write these in context. They do not simply want the definition of a type 1 or type 2 error. They want you to explain it in the context of a problem. So that in context too. Just remember, the entire test has to be in context. So if when you take your final exam, you have to put a giant sticky note on your screen that says, put everything in context, I am totally cool with that. You have to write every single thing in context of the problem. All right, so looking at this example, it says a production manager, same example, guys, collects a random sample of 500 products to find that 15 are defective. Should they shut down their production if they are using the standard alpha level of 5%? So this is where you need your calculator. So you're going to go to stat. Oops, let me turn it on. Stat over to test. And for this one, we're using number 5, which is a 1 proportion z-test. I understand, guys, there's a lot of tests on this list, and we're actually going to get to a lot of them. Just so you can easily tell the difference. So far, all we've done are z-test. Okay, we have 1 proportion z-test. 2 proportions coming up, so we're going to get there. T is going to be the next unit, so all the t-test. So these, you use the z and t test when you're looking at p-values. Down here you have intervals. These are your confidence intervals. So it just depends on what you're looking at. So for this particular one, we are using 1 proportion z-test. My null is 2%. It says he found 15 defective out of 500, and my alternate says greater than. So make sure you fill in everything correctly. Now, this gives you a lot of information, including your z-score, your p-value, p-hat, and your n. The only one we're looking at is p here. So my p-value is 0.055. Oops. Let's see if I can bend this a little bit. There we go. So if my p is 0.055, if we're looking at an alpha level of 5%, this is the symbol for alpha, by the way, so you may see that. Kind of looks like a poorly drawn fish. If my alpha is 0.05, here, this p-value is greater than my alpha level. When my p-value is greater than my alpha level, I retain the null. So in this situation, that means I am saying that yes, my p-value is 0.02. I only have 2% defective products. I can continue my assembly line. However, if my alpha level was 10, now my p-value is less than my alpha. I am going to reject the null, which says no, hey, my p-value is, there are more than 2% defective products. I need to stop this assembly line, fix the problem, and keep going. So depending on which alpha level you're looking at may change your answer. So be careful here. All right, one more example. Flip over. It says a statistics professor has observed that for several years, about 13% of the students who initially enrolled in his introductory statistics class withdrew before the end of the semester. A salesman suggests he try a certain software package that gets students more involved with computers, predicting it will lower the dropout rate. So my hypothesis here, the null would be that P currently has a 13% dropout rate. My alternate, the salesman is saying that if I buy that software package, it's going to lower the dropout rate. So that would make it less than 0.13. Okay. Do not forget conditions, but for the sake of time, I'm not going to write them right now. Don't forget them though. Need them. So always do your hypothesis, then your conditions. Okay. In this situation is asking for a type 1 and type 2 error. I'm just going to briefly state what these are. Type 1 in this case is when he rejected the null, but it was really should have been retained. So he said that in a type 1, in context, don't forget, type 1 saying he rejected the null, he said that the software package did work when it in fact didn't. So a type 2 error would be when he retained, but he should have rejected. So he said the software doesn't work. Oops, that's one word. When it actually does. So why are each of these bad? So well, if the type 1, if the software package works when he said the software package works when it really doesn't, that means he spent his money and bought it, but it really didn't work. So he completely wasted his money. He still had about 13% dropout. A type 2 error is when he says the software package doesn't work when it does. Well, that means he didn't buy the software package, but it really would have helped his dropout rate. So these are the two different types of error. It says, initially 203 students signed up for his introductory statistics course and only 10% dropped out before the end of the semester. Perform a significance test. So we are going here again, stat test 5. This time it is 0.13. Your X value, it didn't actually give you an X value in the problem, so be careful. You have to find it. 10% of 203 is 20.3. You cannot put a decimal in here, so we're going to round that to 20 out of 203. And they said less than this time. So I get a p-value of 0.09. Now, if an alpha level equals 0.05, in this case, my p-value is greater than alpha. I would retain the null, which means that no, the software package does not work. But if I did the 10%, so if I did the alpha equals 10, now my p-value is less than. If my p-value is less, I reject. So please be careful to that alpha level. It matters which one you use. Oops. Come on. All right, last thing I need you to get is the power of the test. This is the potential for the null hypothesis to be rejected. A strong power means we correctly reject a false null. Please pause the video right now. Make sure you write that piece down. A stronger power means we correctly reject a false null. You don't have to actually calculate this. You just need to understand how it works. So your factors that influence the power of your test, if you have a higher significance level, it is a stronger power. So a 10% alpha level is stronger than a 5%. If you have a larger sample size, you have a stronger power. So a sample size of 1,000 is better than a sample size of 500. Just keep in mind that basically the bigger number means a stronger power. Makes sense. So in this example, it says which scenario would give result in the strongest power. If I have a sample of 100 with 5%, sample of 1,000 with 5%, or sample of 1,000 with 10%, that would be letter C because it has the largest sample size and it has the largest alpha level. All right, guys, that is all for chapter 21. I'll post the classwork on the Google Classroom. Talk to you guys later.